Welcome back to another episode of Heavy Wireless, part of the Packet Pushers Podcast Network. My name is Keith Parsons, and today I have with me Josh Hardy of Orb. Josh, what is an Orb?
Orb is an app that is a new way to look at your internet connectivity. So we have a suite of apps you can download on iOS, Android, Mac OS, Windows, Linux. We also have a lightweight measurement sensor that's going to help you measure your connectivity from all the places you care about in a very lightweight way that you can run full time and then see the history of how your network has been performing. This is kind of a new way to look at and understand your internet connectivity, and we think it's a lot more useful than the tools that have existed in the past in this space.
Well, in a previous episode, I interviewed Doug Suttles, and he kind of told a little about the history and where it came from, Ookla and all those kind of things. But a couple of weeks ago in Prague at WOPC, you gave a presentation more about the why part. What does Orb do differently than other throughput testing tools? And you gave some demos. I thought that would be a good thing to share with our audience.
Definitely. So Orb focuses on measuring responsiveness of a network more so than measuring the throughput or the speed of a network. Orb can certainly measure throughput. That is one piece of the puzzle. But we found that most tools over-index on measuring speed, and most specifically, the maximum achievable speed of a given connection. And we found that to be less useful and less relevant to real users' experience on the network. We would find a lot of cases where people would be optimizing their network for speed tests. They would be getting very good speed tests, and they would still not be having a great experience. The company actually started with Jamie Steven after he left Ookla, moving to a cabin near Mount Rainier, and he had challenging connectivity out there. The whole community has challenging connectivity, and when they heard someone from Ookla from Speedtest was moving to the area, they're like, "This is great. He can help us fix our internet problems out here." And he found when he got there that Speedtest really wasn't very helpful. It didn't really tell the story of how poor the connectivity was there, and it didn't give them any recourse to fix or improve their networks. So that's really where the ideation for Orb started.
Well, one of the things I've found with my customers is they want me to design to have really, really fast speed tests. At sometimes it's at the detriment of their actual Wi-Fi. To get a bigger speed test, I might have to go to 80 megahertz wide channels when they have lots of co-channel interference. And they'd actually have better experience if they didn't use the wide channels, but they just like chasing that number. So how do you convince people that it's not about just the top speed number?
Absolutely. So yeah, the over-indexing on speed can be a real problem because, of course, it's important for certain use cases, but it's not the only piece of the experience that matters to users. And if you're really focusing on that, like you said, you will optimize the network in such a way that will be detrimental to responsiveness. Could be detrimental in other ways. So we feel at Orb like we really need to give people a way to understand responsiveness. And I've used that word a few times, but I haven't really defined it. So I'll say how we think about it here. We think of responsiveness as how quickly a network can handle the activities that you're doing day to day. So web browsing, whatever it is, how quickly does that come back to you? It's not actually throughput, which is more the size of the pipe of how much data, assuming you're downloading huge files or something, how much data can you possibly get the connection to scale up to? It's more about the feel in the moment of you make a search query, you say something to an LLM or an assistant. How long does it take that data to get to those internet services and then back to you? And that's really what we feel people experience the most on their network, and they don't have a good framework or language to measure, understand, and optimize for that piece of the connection. So we call that responsiveness. And that's something that we measure continuously in Orb. We think that measuring responsiveness while you're actually using the network is hugely beneficial. Gives you the real life working conditions of what's happening when I'm on a Zoom call, when my kids are playing Roblox, whatever it might be, you see the real responsiveness of your network under those conditions rather than some simulated conditions like what if I'm downloading the largest file imaginable.
Well, you mentioned that it's continuous, and my first reaction is, well, I wouldn't want to run a throughput test continuously because it puts an excess load on my network. How I'm going to use the term you probably use, lightweight. What's the actual data that you're using, and is it affecting the actual, for our audience, Wi-Fi, the network Wi-Fi throughput? Are you putting more than is necessary to get that information?
So we try to be, like you said, very lightweight in our measurement and our responsiveness measurement because we realized early on that we were going to want to measure continuously. Again, back to Jamie's experience moving to the woods, that's really what he found he needed was a continuous measurement of what's happening, for 5 seconds every few minutes, because that's what people are feeling. That's what people are being impacted by. So we really designed it to be very low traffic volume so that we could measure it continuously and sort of paint a picture of what the experience has been over time. So in terms of what actual volume we're talking about here, it's packet level measurement. So we're generally doing about 2 packets per second. These are very small packets. We do support several measurement protocols. I think a lot of people, when they first look at Orb, they assume it's based on ping, ICMP, much like ping utilities that have been around for a long time. That is one of the mechanisms, but we actually put a lot of effort into making sure that we're measuring realistic protocols, realistic traffic paths as much as possible. So we have several protocols, several destination endpoints that we will be testing to on the internet. But across all of those, it's very much packet level measurement. So on average, we're pushing about 2 packets per second round trip. And those are, again, small packets. I think total it's about 40 megabytes per day of data, which is a little bit of data going over your network, obviously, but relative to a speed test, which can push a gigabit of data in a few seconds, it's nothing. So that's been our goal, is to keep it as lightweight and low impact as possible, such that you can run it from a lot of points in your network to understand the internet experience at different places or for different devices, and continuously.
One of the things you presented in Prague was you walked the audience through trying to find which things had the most effect or didn't have an effect. Could you walk us through that? Obviously, we are on audio. We're going to have to describe what you showed in the screen, but could you tell us how that goes?
Definitely. Yeah, so one of the challenges we faced early on is finding a measurement of responsiveness. So again, I sort of described the concept of, it's how quickly a website responds. It's how quickly an app can load data. That aspect of your connection, and I think fundamentally people understand that. But when you try to bring that down to what measurement are we talking about here, usually it comes down to latency. People understand latency as the round trip time. We found that there are some fundamental challenges with understandability of latency. So we worked on our what we call lag measurement. So this is a measurement of what is the actual experience lag going to be with these underlying network conditions. So we have measurement methodology based on in Prague I described it as sort of vanilla protocol stuff. So it's not a specific video protocol. It's not a specific application transport protocol. It is sort of our take at how do protocols at large respond to these underlying network conditions, and how can we simulate that to measure that accurately and give people a evergreen understanding or sort of an evergreen definition of what is the responsiveness of this network? What is the lag? What am I going to experience?
And so when you say lag, you're including in that things that we're used to talking about, latency, jitter, packet loss?
Correct. So lag includes the impacts of those. This is something that we get asked a lot, frankly, is sort of how do you combine those? What's the math to combine those underlying metrics into lag? And it's not actually just a mathematical aggregation of those underlying metrics. We did start there to be blunt. We started with measuring the underlying metrics and trying to combine them in some way to come up with a lag and ultimately a responsiveness metric. And we found it to be very difficult uh, because it really depends on packet ordering. 3% packet loss can feel very differently. If that 3% happens in a big burst all at once, you might have a big glitch or lag on your network that you feel and you can tell something happened. If that 3% packet loss is very evenly sprinkled throughout, a few minutes, you likely won't feel it at all, depending on what you're doing. So that was sort of what brought us to the need for an active measurement that includes the impacts of packet loss, jitter, and latency, but is not solely derived from them.
What? So I'm a little confused. What's the difference? How do you calculate the impact of something rather than just the measurement itself?
So what we're doing is we are measuring what we call action to response. So from the time you take an action, meaning you might send a query, you might request a website, to the time you get a response, an appreciable response that is aware of your action from an internet service. So that's high level what people usually think of as latency. It's the round trip time. What's the amount of time from when I do something to when the server gets back to me on that? And loss and jitter are really where it becomes a bit different and why we felt we needed to introduce lag. Um, so if a packet is lost, for example, many measurements will just say, well, your round trip time didn't necessarily change, but a packet was lost. So here's two independent pieces of information, do with them what you will. And it can actually be very, very challenging to understand how those two things combine. Just like I said, that we had a challenge coming up with an aggregation or a algorithm for combining those things to explain the impact. It's very hard for our minds to do the same thing. If you say your round trip time is 20 milliseconds and you have 3% packet loss, very difficult to understand what that's going to actually mean for you versus measuring and doing the what I would call protocol stuff of, all right, if we see that packet lost, let's retransmit. Let's not consider that action complete yet. That action has not received a response yet. So we're going to retransmit. And if the retransmit succeeds, then we consider the action complete. So in the packet loss example, that might increase your lag to 50 or 60 milliseconds because you had to wait, you didn't see the packet, you had to retransmit, then you saw the response from your action. And that's sort of what protocols are going to be doing. That's what QUIC and TCP are going to be doing. And that's what you're going to feel is a 60 millisecond quote unquote latency rather than feeling 20 milliseconds of latency and loss. You can't feel loss. So that's why we kind of brought those together.
Good. Well, you walked through stepping through different types of losses and how they have different effects, and even asked the audience to predict what the next step was going to happen. Can you walk us through that kind of demonstration you did?
Definitely. So yeah, at WLPC, I tried to walk through at a high level some of the research we did to try to find what metric would be most indicative of user experience. And as a proxy, I used the website render time of a website. We were loading orb.net over and over again with different network conditions and trying to see how that user experience of loading a website, which is obviously just one specific experience, but it's a pretty common one. So it's a good one to start with and understand and make sure that our metric sort of passes muster for that test. And what we saw, we started with speed actually. So we started with throughput conditions. And we saw across most of the range of throughput. So if we started with gigabit, the speed or the page loads very quickly. We went down to 500 megabits per second. It still loads very quickly. In fact, no difference. 200 megabits per second, still no difference. 100 megabits per second, still no difference. And this was sort of trying to showcase speed matters for some use cases, but it's certainly not the only metric you should be looking at, because look at this huge range of speeds that people would consider vastly different levels of quality for a network. If you say my network can do 100 megabits per second, in 2025, most people will say that's nothing. You need to upgrade your gear. If you say it can do gigabit, it's like, okay, that's decent. The reality is those two have very, very similar experiences for most use cases, assuming your latency and other metrics are the same. So we started by showing that speed is not necessarily the metric to be judging your network by when these huge ranges of speed values have little to no impact on your experience. So then we move to latency, and latency, you can see, does have a huge impact on web browsing experience, very in a sort of linear fashion. So if you add 10 milliseconds of latency, you'll immediately see the impact of that on your page load time. If you add 20 milliseconds, you'll immediately see increase, and it actually is more than a one-for-one increase. So you have a lot of round trips involved in loading a website and in most network actions, of course. You've got the SSL handshake, you've got the ACK frames coming back, you've got a lot of places where round trip times are actually very important to getting web content loaded in your browser very quickly. So we see a huge impact from small deviations in latency. That kind of leads us to say, okay, latency is on the right track. This is much more impactful to an experience than throughput. So we should be optimizing for this. And that's where we kind of led to the next logical step of we need an understandable single metric here to help people understand this responsiveness, latency in a way that they can't really today. Speed is very convenient in that it's very understandable, right? You can put it on a gauge, you can understand, okay, this is higher, better. I might not understand the underlying mechanics, but I can understand that if I get over 500, this is going to be really fast. People don't have that same kind of understanding in that single metric for responsiveness, and that's what we're trying to give them with lag.
Okay. I sometimes call that drag racing school buses. Yes, you can take two school buses and put them on a drag strip and see who's the fastest, but that's not what school buses are for. So putting a speed test, and I'm using that in a generic term, a throughput test gives you that one metric, but that's not what you're going to be feeling. So I like the demonstration you gave to show it didn't make any difference by changing the speed. It made a big difference by changing the latency. What other things can you change that would have an effect as well?
So yeah, of course, there's packet loss and jitter, and these are things that, again, in sort of the understandability of responsiveness, people usually gravitate towards latency, and they do generally understand latency, but when loss and jitter get involved, it's usually pretty unclear, right? It's especially jitter. It will give you some information on packet inter-arrival variance between packets, but I think most folks, even in the industry, would be pretty hard pressed to say, what is that going to do to my experience? What is high jitter doing? Why would I care, frankly? And so usually it gets kind of ignored. And this is where we dug in with one of our advisors, who's one of the authors of the Quick protocol, to really understand, okay, what are protocols doing with these underlying conditions, and what experience are users going to have when those conditions occur? And for example, jitter. Often what will happen in protocols, from video protocols to application protocols, they will set some high watermark to understand okay, some of my packets are coming back quickly, but some of them are coming back very slowly. I'm going to adjust my expectations. I'm going to adjust my frame rate, et cetera, to the high watermark of these packets because I can't be fluctuating up and down continuously. So that's where, those kinds of things that are very difficult for us as humans seeing a number, like your jitter is 38 milliseconds, to understand the impact. But when you have a measurement that's including the impacts of that and taking the high watermark and understanding as the latency fluctuates up and down that your experience lag on most protocols is going to increase. That gives you that single metric. And you can say, okay, I don't know exactly, I can see that the cause is jitter, but what I understand is my lag went up to 65 milliseconds. And I could feel that. I saw that the websites are a bit slower, et cetera.
So, like you described a little while ago with the packet loss, you made that round trip lag include jitter numbers as well as latency numbers as well as the packet loss.
Correct. Yeah, and again, it's a measurement methodology that includes the impacts of those things, right? So it's by our measurement methodology doing the same type of retransmission and high watermarking as protocols, we can say what's the resulting round trip time that measurement protocol saw and measure that as lag.
Well, in your application on the interface, you have a place where you can go look at responsiveness, and it's kind of separate. But you also have this big circle with a number, like a score. How much of that score is tied to the responsiveness versus not just responsiveness, but responsiveness over time? Does it change?
Yeah, definitely. So we tried to make Orb understandable at multiple levels. And this is something, we wanted Orb to be useful to industry, to nerds who want the underlying details of, what caused this lag. Was it a spike in packet loss? Was there, something going on at the low level? I want to understand those details. But we don't want to just throw all those details in front of everyone and expect them to understand them. So to accomplish that, we came up with our orb scoring methodology. So this is where we give a connection a score on its internet experience. So at the very top level, we have the top level score is orb score. So if you're just looking for one number and one sort of uh, you know color range to understand like how good is this connection, orb score is the place to look. So it's a 0 to 100 score and we give it a color status color so you can kind of understand bright green is very, very good. It starts to get yellow, starts to get orange. This is going to be not so good. That happens around 70 to 80 is where you start to understand like, okay, this is not performing that well. It's working, but not performing that well. And so we summarize your entire connection and your entire experience into an orb score.
Well,
If you want to dive in a little bit deeper, we break that out into what are the components of that org score. What do we think goes into that experience? And that is responsiveness, reliability, and speed. So we do think that throughput testing, speed testing is still a component of your experience. For certain use cases, that's going to be impactful on what you can do and how quickly you can do it. And I'll get into how we test speed. It's a little bit different and a little bit more lightweight than other tools, as you might expect, given our ethos of lightweight measurement. But the first two, responsiveness and reliability, we think are the most impactful to your internet experience. We give each of these components a score of its own, so the same 0 to 100 score, so you can understand. Okay, I have really good speed, but my responsiveness is not great, or I have good responsiveness, but I've got a reliability issue. And responsiveness and reliability are both based on these underlying measurements of lag. So watching lag over time and saying, how responsive has this network been over time? And then reliability is specifically how often has it been responsive and usable versus how often has it been unusable.
Well, just a little side note. On your big orb score, the total one, underneath it, you have words that kind of describe instant and powerful, lightning fast reactions with a strong foundation. How did you come up with those little taglines?
Good question.
Somebody was having
That's an
fun with it.
example. Yeah, we definitely had some fun with those. That's an example, I would say, of uh, startup stuff where we needed we wanted to describe to users, if you don't quite understand the scoring yet, how can you uh, understand what this means and what you should be taking away from this. Of course, we have other mechanisms of doing that as well. We have some help content. You can click on the orb score and get the number scale and some symbols for sort of what to expect at different levels of the scale, etc. But we really wanted something that if you weren't yet acclimated and you didn't yet understand the scoring system, what should I take away from this? And so, it's pretty simple heuristic, honestly, of some kind of ranges of the underlying values. We wanted people to also understand and sort of see a bit deeper. Like I mentioned, orb score tells you one summary metric. If that's not good, you might wonder why. So you might want to look deeper into, is this a speed issue? Is this a responsiveness issue, et cetera? And those words under give you the first sort of indication of that. That's where we kind of took all of these ranges of the various cases of, oh, you've got a really fast network, speed is high, but your reliability is actually low. How would we describe that? So I think, that was kind of us taking our pass at how would we explain this to users. Obviously, try to do it in a lightweight and fun way of how would we explain to this user what they're seeing in just a sentence so that they can immediately get something to take away from this app and this experience. And of course, if they want to dive deeper, if they really want to keep going layers and layers deeper until they get to the raw underlying metrics, they can. But if they just want to take instant and powerful and say, okay, looks like everything's good, that's great.
Have you seen many orb scores of 100?
We have not. So this is actually a common question about our scoring methodology. I think many similar scoring methodologies are based on a population, which would be sort of okay, among the population of orb users, am I in the 99th percentile or the 98th percentile, and that would be what the score would be based on. We actually don't do that in orb. We wanted a consistent and evergreen scoring approach such that you can understand that a 98 means a 98. Doesn't matter what else is happening in your region. It doesn't matter how internet has changed over the last year. A 98 means a very specific experience, and we wanted to keep it that way. So in terms of doing that, we needed to anchor it to something. So rather than anchoring a 100 score to what's the best score we've seen in the last month, or the best experience we've seen in the last month, we actually anchored it to an ideal internet experience. So a 100 is by definition sort of a perfect internet experience. There's zero latency. You can download anything and it's instant. There is sort of no lag, no delay, no loss of any kind anywhere, and it's always up. So that is by definition a 100. Realistically, that's not possible outside of maybe a lab. If you had a lab or something on device where you were connecting to content that was local, you might be able to hit 100 with rounding error. But that was kind of our goal, was to make it evergreen and something that we could always be striving to achieve. So as an industry, as an ISP, et cetera, there's always a higher orb score to be working towards. We've seen 98, I think, is the highest I've seen in practice. Obviously, there's also decimal precision here that we haven't got to. Eventually, we might expose ability to say, 98.4 versus 98.6, something like that. It does get exponentially harder as the score increases to increase the score. So getting from a 92 to a 93 is significantly easier than getting from a 90 97 to a 98. The difference between a 97 and a 98 can be, multi-gigabit speed differences and latencies that are shockingly low. But,
Well, what's your Orb score at your home network?
well, so I'm about a 91. I think that in our team, so we have an Orb dashboard set up for our team so we can see all of our home networks. I think Doug's house is he's on Ziply Fiber. I think he's the current leader of our leaderboard. He's the one who sometimes hits 98. He's usually a 96 to a 97. I'm pretty happy at a 91. I live a little bit outside of the city. I'm on a cable Xfinity connection here. I think this is an example too of on paper my connection is much less than Doug's, and you see that in the Orb score obviously. But it's worth noting that we're both above 90, meaning we're both having an excellent internet experience. I think this call is working great. We're able to communicate over my connection just fine. My family has a great experience with the internet here, even though I think we have a lowly 35 megabits per second of upload. But in terms of experience, 91 tracks and feels like the experience I'm having.
Well, I appreciate your time today talking about some of the basics and the fundamentals behind how Orb works. If someone wanted to track you down, how would they find you?
Yeah, you can find me on LinkedIn. Search Josh Hardy. I'm still working on the SEO a little bit on that name. There's a lot of Josh Hardys out there, but I'm getting there, so you should find me. You can also go to orb.net, and we have an about page with our whole team there and links to social and LinkedIn, etc.
You've been listening to another episode of Heavy Wireless, part of the Packet Pushers Podcast Network. We've been talking about Orb and some of the ways that it calculates an Orb score that is tacitly better than looking at only speed. If you have any other ideas for other podcast episodes, topics, ideas you'd like, please feel free to leave those in the comments. And we'll talk with you on the next episode.